Okay, sorry for the delay, everyone. This is Mike Zukowski at OneRain. I'm going to be showing you guys our newest cloud application, which is a TDMA manager for managing TDMA networks, specifically as they relate to ALERT2 gauge networks. We have a number of people on who have networks in different stages. There's lots of you online right now who have standard legacy alert networks and a few people who have ALERT2 networks, and also some people who are in the midst of upgrading from ALERT to ALERT2. And so this tool has really been specifically designed for helping you in that transition from ALERT to ALERT2. And in addition to that, kind of going forward long term, it's been designed as a way to help you manage these networks. Okay, so I'm going to jump right in. So as I mentioned, this is a cloud-based service. I'm going to log in here, or not log in, but just show you the interface to start off. So as always, if anybody has any questions, please just use the chat, and we'll try and address them as they come in or put them off if I'm going to cover them a little bit later. So just kind of a little bit of background on this application. So here locally in the Denver Front Range, a pretty large legacy alert network of about 210 gauges total. And so we've been working on this upgrade for a few years now, starting with the backbone, and now we're working on getting each of the gauges implemented. It's a fairly complex network with 5 transceivers or repeaters, whatever terminology you use for them, and a considerable number of gauging sites, as I said, over 200. In addition to it, it's complex in that a number of different agencies share the network. So we have Denver, the city of Boulder, Boulder County, Douglas County, Jefferson County. So a lot of different counties and agencies touch this network and do maintenance. We perform maintenance on about 80% of the sites, but there's a few other entities out there who perform their own maintenance. So we had started off with the standard spreadsheet to keep track of all of the TDMA characteristics that we needed to track. As we got deeper and further along into the upgrade, we recognized that we needed a tool that was more accessible to everyone and also that would keep track of all changes regardless of who did it. As many of you know, if you have a spreadsheet, if you just store it locally, the changes don't make it across everywhere, things like that. In addition, we wanted to provide ourselves with a few more tools for keeping track of capacities and frequencies, give us an idea of what's going on with the path for the radio network, things like that. And so out of that need, we started developing the software. It's kind of expanded as we've worked with different agencies out in California, New Mexico, et cetera, as we're helping them implement their ALERT2 upgrades and networks. And so that's kind of the basic history of this. The application, as I mentioned, is serviced from our cloud network, which we host in a service center, an IT hardened center here in Colorado. Okay, so I'm going to jump right in. For the first part of this, I'm actually going to go to the help section, because one thing I'd like to do, since we do have a wide variety of people on this webinar, is just kind of go over some terminology that will help us talk about the software and why we name things certain ways and why we utilize some things differently in ALERT2 versus ALERT. So I'm just going to hit the help. So I guess before I hit the help, one thing to note, if anyone's familiar with our inventory application, you'll note that the website looks very similar, very mobile friendly. It's responsive design. So if I shrink it down, I'm going to get rid of this behind the scenes there. So if I shrink it down, you'll note that everything kind of moves with me, and you'll see that more when we have additional panels on the screen. But very friendly for your tablets, but also the same display on your desktop. So you kind of see the same thing regardless of what device you're using. Okay, so as I mentioned, I'm going to go to the help. So in the upper right-hand corner here, I'm going to use this gear, which many of you are probably familiar with from other websites, kind of indicates the settings. I'm going to hit settings. You'll see a help and a login screen. I'm going to go to the help first before we log in. A somewhat complete help document. help us learn some terminology. This is the part I'm going to cover first before we jump in, is the terminology. But we also have some instructions and basic directions for setting up networks and things like that. Okay, so the first thing I want to talk about for those of you who have legacy ALERT networks is some of the differences between ALERT and ALERT2 and why we need this tool for ALERT2. So first off, the ALERT networks that many of you have out there, the gauges are set up and transmit in what is called an Aloha mode. And so Aloha is an older technology process for getting data in from the field, where basically when the individual gauges out in the field have something to say, they say it, whether it's their timer reports or an event report. If they have a piece of data they know they need to send, all they do is just transmit it and they hope the other side hears it. In contrast to that, ALERT2 uses a TDMA protocol, which stands for time division multiple access. And the big difference between the two is now in ALERT2, instead of just saying a piece of information and transmitting it when it's whenever it thinks it has something to say, in ALERT2, each individual station has its own special time slot when they are to transmit in. So what that allows us to do is eliminate contention on the network. So in ALERT, when it's raining hard and many gauges are starting to transmit all at once, two gauges can transmit at the same time or almost at the same time. And what can happen is over the air in the RF, these messages can get corrupted, and typically you will not receive either. Maybe you receive one, maybe you receive one that has some corruption in the message, and we get a bad data point. So one of the biggest strengths of TDMA is that it allows for a better quality piece of data coming across the air, because there's no other messages in the air to corrupt it, and the reception of it is considerably improved. So therefore, the reliability of getting the messages is improved. So that's the big difference. But when we introduce this idea of time division multiple access, or TDMA, we need to know a lot more things about the frequency as a whole, specifically how often do we get to transmit, when do we transmit, because each individual station now needs to have special characteristics associated with it to let it know when it is its turn to transmit, so it doesn't step on other gauges and can help guarantee its messages get in. So that's the difference kind of between a legacy ALERT and ALERT2 from a really high level. So a few of the terms that we need to cover real quick before we get into the software related to the TDMA are related to things like frame length and block length. So let's talk about, I'm going to start at the top real quick with the software and then we'll come back down to this frame length. But currently right now, everyone is intermixed in terms of and segregated by their agency. So you can view other agencies' networks, but only the agency who owns the network can do any editing or adding to it. So each agency can own a network or multiple networks. So a network, as it states pretty clearly here, it's a combination of different frequencies and includes the stations. So we have receivers, which are going to be your base stations, transmitters, typically your gauging sites, and then transceivers. The other term you often hear is repeaters. So these are transceivers or gauges that can listen on a specific frequency for other gauge reports, and they can pass them along on a different frequency or the same frequency, but typically a different frequency. Okay, so within each network, a network is built up of stations of one of those three types: receivers, transmitters, and transceivers. Then at the frequency level, we have this idea of frame length. And here's where things get a little bit confusing for TDMA and where the tool really provides a lot of value. So a frame length determines how often a gauge can transmit. So let's kind of take it up a level and say, okay, I have 60 gauges out into the field. So if we define a frequency frame length, a typical frame length for 60 gauges would either be 60 seconds or 120 seconds, which means that if you have your gauge set up to transmit one time per frame, then, if it's a 120-second frame, we will get to transmit one time every 2 minutes. Now, we can send multiple data reports in there, but it basically tells us how often the gauge will have a chance to transmit. So this frame length is stored and is part of each individual frequency. Block length and slot length, we're mostly going to talk about slot length in the software. A slot length is how much time you've allocated to each individual gauge or each station that it gets to transmit in. So typically those are set up to 500 milliseconds or half a second for standard gauges. A lot of times you'll see weather stations maybe will provide 1 whole second just to allow for additional information to transmit. Block length, we're not going to cover too much here, but basically the ALERT2 protocol is made up and defined that a block is 250 milliseconds. But typically in the software we're going to talk about slot length, which is a slot is a collection of blocks, but really slot length is the term most people are using these days. A couple other things related to capacity, frame capacity, related to how much data we can transmit. Based on the slot lengths, a typical 750 millisecond slot length in ALERT2 will allow us to transmit 75 bytes of data successfully during that time frame. So when we start looking at some of these transceivers, we'll see things like frame capacity. So how many bytes can we actually get through during the time that we've specified? Other things related to that, so the number of slots we've used, how many are free, things like that. So we'll see these again, but I just really wanted to cover the difference between ALERT and ALERT2 in terms of Aloha and TDMA. And if you've seen some of our recent webinars, I think Scott has done a very good job of walking through and kind of giving a broad overview of the differences between an ALERT and ALERT2. Okay, so I'm going to close the help manual here. And so now again, we're back on the home page or dashboard. You can see I have a number of options in these links here, kind of these higher level links, which you'll note are also at the top and always available. So agencies. So as I mentioned for agencies, so currently we're looking at a collection of Southern California alert networks. And so, you'll recognize many of these agencies, Los Angeles County, Orange County, et cetera. I think today we'll use Santa Barbara County. So as I mentioned, agencies own networks. So in this case, they have one network defined. There isn't a limit on networks. You can have multiple networks. I would say most agencies have one network. One of the really nice features of this software application is that we can download and export networks and then re-import them really easily, which hopefully I'll get to a little bit later in the webinar. But what that allows you to do is you can, let's say we use this network and we want to make some pretty drastic changes, we can actually export it out, re-import it in as a new network maybe, make a lot of changes. We'd have 2 networks here and then make a final decision once we have one. Okay, I'm going to jump right in. So the first thing I'm going to do is kind of cover this existing Santa Barbara County's network, just to kind of give everyone a feel for what the software does, what its capabilities are, and then we'll probably walk through how do you set up and start from scratch a new network. Okay, so I'm going to click on networks here, Santa Barbara. I could have also gone up to the top bar and selected networks, and you'll see most of it looks familiar because they kind of match the agency names, but a list of all the networks that are currently available for viewing inside this collection. So again, I'm just going to hit Santa Barbara. So as is going to be the case with most things here, we kind of give you a quick summary of whatever component of the software we're on. So in this case, we're on the network. So, Santa Barbara, this is the 4th implementation of it. That's just how we're doing as we're helping them design their network. This is the 4th iteration. We'll talk about the type a little bit later. Units, US, you can also do metric if you use meters and kilometers instead of miles. A list of the stations that are composed within the network. They have a pretty big network as well, 85 different stations, which would include their all their transmitters, transceivers or repeaters, which are shown up as this icon showing that there's a frequency coming in and a frequency leaving the antenna. And also their base stations, which I'll scroll down just to show you the icon there. The other thing to note here is that the network is composed of two frequencies, a frequency that they've called SB main F5, which probably doesn't mean a lot to anyone online here, and the same thing upstream F6. But basically, their network is split into two frequencies. And so I'll try and visualize that here in a sec as the next step. So you see next to the network here, we have a couple of buttons. First one, this is an export button, which will download their configuration into an Excel format, a CSV format. And the next button is a network map. Just allows you to help visualize the network. You know, as you can see, they have a lot of different gauges, so this is a little bit tough to look at in this small box. So I'm going to use this maximize button here to zoom out, basically give me some more screen room. And if I click on any of these icons, you'll see I get a little bit of information here, and this is also a link to the transmitter. I'm going to add, let's add the name to the station so we can see what we're doing. So currently I'm set up in location. Since each of these have Latin longs associated with them, each of these stations, this basically tries to plot it in a manner that's so that the gauges are relative to each other spatially as they would be in the real world. I'm going to select the different ones. So there's a bunch of different ones we can use, random, circles, and grids. I'm going to use the, let's do the circle. And you'll see it plots them in a big circle. Again, a little bit hard to read, but basically what I want to show you is kind of the layout of their network real quick. So what I'm going to do, these blue squares are receivers, which in this case would be their base stations. The triangles are transceivers or repeaters, and then the circles are gauging stations. So just to kind of give you an idea of the layout of their network, I'm just going to drag these off to the side just so we can see. And each of these lines between them, the spokes on this wheel, are what we have termed routes, meaning that each of these gauges can talk to, and if you see here, if we zoom in, you'll see the arrowhead. So for instance, this LaCumbra transceiver, it listens to a bunch of these gauges all up in this circle here, and then transmits them, if you can see the head of the arrow, directly to the base stations. One thing to note here is this repeater doesn't actually transmit to the base stations. We can see that already. I'll move this one down a little bit. Move this transceiver plowshare over. And then Figueroa Mountain. Okay, so this kind of gives us a little bit better idea of their network. And I'm mostly showing this so as we walk through the software, you'll kind of get an understanding of why we see a few different things related to capacity being different. So as you can see here, the gauges transmit to Twitchell and Plowshare, and actually they transmit to all of the repeaters. So each of these repeaters has gauges that it listens to directly, and the base stations also listen to a few gauges directly. The gauges that are heard by Twitchell and Plowshare are then repeated to this Figueroa Mountain. Figueroa Mountain transmits to LaCumbra, and LaCumbra transmits into the base stations. If they had just alert gauges, we could plot those on here as well. We can grab an image of this if we want to share it with anyone. Pass routes versus preferred routes. So pass routes are any station that this transceiver can hear will be represented by one of these route lines. Whereas preferred, if we select preferred, only one route will be shown, which is what we've termed as the preferred route. So as you can see here, there's only one line drawn between each of these stations and one of the either the base stations or the transceivers. Okay, so I'm going to get out of this by minimizing it. Okay, and the next thing we're going to do is look at frequencies. So I'm going to go back to the Santa Barbara network. They have two frequencies, so I'm going to click on just the first one here. So now we're getting a representation of this frequency. They've named it this main F5. Currently it's set up to be 171.9 megahertz. They've described it as the repeater input, so most likely two of their repeaters or perhaps three of their repeaters are listening on this gauge frequency. If you remember, we talked about frame a little bit when we looked at the help document. So the frame for this frequency is set up to be between 0 and 60 seconds. So it's a 60-second frame length. And then the default slot size and block size is 500 milliseconds or half a second and 250. As we kind of mentioned before, slots are made up of blocks. So for the most part, we're going to ignore blocks for this training. We get a capacity, we get an idea of how many slots have been used. So a little over 45 slots, counting for 31 seconds. And then this graph is going to give us an idea of when these transmissions occur. So if you think about this graph, we're looking at a time frame of 0 to 60 seconds with the blue slots, the blue representing slots that have been filled in and the whites representing available slots. We get a list of stations associated with this frequency. So if you remember, they had about 85 stations, I think, and about 49 of them are currently associated with this frequency, meaning they either transmit on this frequency or listen to this frequency. Reservations. So currently there's no reservations defined, but if we did define one, this would let us block out large periods of time. So we could block out periods of this frame for either future use or for, you know, maybe we have another agency that shares the frequency with us. Maybe we want to block out 10 half-second slots because we know we're going to upgrade 10 gauges over the next year, and therefore we want to put those in a specific slot bank, and we can use the reservations to make sure that no one else can put a gauge in on that slot. Okay, so this is kind of the frequency summary, and if we go back to the network, we could look at the other frequency. A little bit less is used, 40 stations versus the 45, and again, this is a 60-second frame for this frequency as well. Okay, so I'm going to go right to the a station. In this case, it's going to be just a transmitter. You can tell that from the icon. We also write it down here, transmitter. We also provide the protocol. In this case, it's ALERT2. And actually, for this network, they're all going to be ALERT2. So I'm going to click on the station. The other way I could have gotten to this station is up in the bar, the navigation bar at the top. If I click stations, you'll see we kind of give you a map trying to plot where these station locations are, which you can see most of them are, all of them are within Santa Barbara County here. Here's the city of Santa Barbara on California coast. This list group here is, we have some filtering, so if they had alert gauges, we could filter on that. In this case, they do not have any. The other thing we can do is filter on the transmit type. So number of transmitters, they have 79 transmitters. If we look at transceivers, you know, we'll see those same 4 that we saw on the network map. So first off, I'm going to look at the transmitter. Let's just go to this reservoir. Okay, so again, we get some basic information about the station. It's an ALERT2 gauge, it's a transmitter. Its source address, which in ALERT2, which would also relate to its SAMS address, Source Address Management System, which would be found at alert2.org, should match this. Lat long, what is its elevation, and what's its antenna height. This is probably incorrect. I doubt at this reservoir there's a 555-foot antenna mast. Okay, you can see it's associated or linked with the frequency, this SB upstream F6. So this gauge is transmitting on 169.5125. Routes are the gauges or the stations that can listen to this frequency. So when we transmit from this reservoir, it will be listened to. Figueroa Mountain, Plowshare, and Twitchell are all listening on that frequency. As you can see, we've set up this block, so whether it's through path listing or whether it's through some sort of physical path obstruction, maybe a mountain, we believe that this Twitchell gauge cannot hear this reservoir transmission. However, Figueroa Mountain and Plowshare can. And the reason this routes table here is important is when we start doing capacity calculations for whether or not Figueroa Mountain has been given a slot large enough to be able to pass all of the gauges it can hear onto the base station. If this route is blocked, this gauge will not be included in that calculation, but in this case, Figueroa Mountain, it is passed, therefore the calculation will occur, it'll be included in that calculation. Okay, so the next thing we'll see here is the slot. So we're looking at a slot offset of 3 seconds and a slot length of ½ a second. Based on this ½ slot, and since its message type is default, which is going to be a standard ALERT2 message, general sensor report most likely, we will be trying to transmit approximately 25 bytes on average, and we have a capacity of 75 bytes. So therefore, we're good. We're only using up about a third of the slot capacity, but this 25 bytes will fluctuate. We might end up sending 2 messages during this transmission, which would be more than okay. We have plenty of space, plenty of unused capacity at this slot level. Okay. Again, we get a frame summary and things like that to show us where we're transmitting. I'm actually going to log out and log back in, or log in, since I'm logged out, just to show from the station point of view some of the additional features where you edit slots and things like that. So I'm going to log in. I'm going to switch to Ventura because I've been working with them on their network lately. Just I have a little bit better knowledge of it in case I run into any issues. I'm going to pick a station in the Ventura network, so networks, Ventura. So I'm just filtering right now, so I only see Ventura ones. And let's just do the first one in this list as well, Alamo Mountain. Part of the reason I did this was so that we can see these frame summaries a little bit better. The Santa Barbara one was a little bit hard to see, I thought, especially on through the webinar. Okay, so if we look in this, kind of a similar thing we're looking at again, where we have a standard transmitter. It can be heard, theoretically heard by 3 different transceivers, but we believe it's actually only heard at one, this Cesar Mountain. Again, we're trying to send 25 bytes through, but we've defined a capacity of 75 bytes. And if we look at this frame summary, I'm going to, 2 things we can do here. One, we can download the frame summary, or we can visualize it a little bit larger. I'm going to use the visualization tool. Kind of 2 different looks at it. Both of these are time-based graphs. So starting on the left-hand side, we're looking at 0 seconds into the frame. It's a 60-second frame, I believe, so this would be 60 seconds. We can see our station here is colored orange, so we're transmitting, maybe just a little bit into the frame. So if I click on it, we're on Alamo Mountain, so we're transmitting with a slot offset of 5, so 5 seconds into the frame. So every 60 seconds, 5 seconds into that frame, we have 500 milliseconds or ½ a second to transmit all the data we want. So this pie chart is really the same graph, just in a pie form or donut form, where time here is 0 and where it's orange is 5 seconds in. This tool's nice. You can kind of see what else is transmitting near it. Arroyo Leopoltis. So the other graph that's associated with this visualization is this frame latency. I'm just going to click on that one. So the top graph should look familiar. It's actually the same graph from this frame summary. However, the second graph is obviously different. What we're showing here is that, okay, Alamo Mountain transmits. This is a 60-second frame. It gets to transmit at this location in the frame, so 5 seconds into the frame. The second graph is showing its primary receive station's frame. So in this case, we're looking at Cesar, since that's the preferred route, and in this case, the only passed route. It transmits on 171.05, which is different than what Alamo Mountain, the gauge of interest, transmits on. But as you can see here, this station, which is referring to Cesar here, actually transmits pretty regularly, and in this case, it gets to transmit 6 different times within this frame. So what we can see here, the information we're gathering here is that once this Alamo Mountain transmits 5 seconds into the frame, approximately 5 seconds later, this information that it transmitted will be retransmitted from CSAR, and in this case it makes it all the way to the base station. The reason this is valuable is, let's say CSAR only had this last block here to transmit in, and these first 5 orange sections were, let's say, white, so nothing transmitted into it. What we'd note is that there's a possibility of 40 seconds of latency from after Alamo Mountain transmits before CSAR transmits again. So this is just a nice visualization of how much lag there's going to be between transmission from the gauge and then once that transmission from the repeater happens. So again, please use the chat if any questions come up. I'm going to go back to the actual station here. So again, some more information. Since I logged in, you'll note I have a few different icons and buttons that show up. For the slot, let's say I want to edit the slot. I'm not happy with this 5 seconds in. Maybe the slot before it needs additional time, so I have to move this one. So what I'm going to do is I'm just going to hit Edit Slot. Again, similar visualization. This time we have a zoom tool, so this bottom graph allows us to zoom in to look a little bit deeper. There's a zoom out here. We can zoom in across somewhere else. If I want to move the slot, so right now it's set up to be 5 seconds in, and so I can use this scroll bar. I'm going to hit plus, and as you can see up top, we'll start to move since I'm adding time to it. So now I'm trying to get it to, let's say I want it to transmit 8 seconds in. What you'll note here is that this is red, so we're telling you some other gauge has this slot, so we're not going to let you save this slot. You could change its length, things like that. The other way to do it is I could just hand type in here. Let's say maybe we want to do it 40 seconds in. So you'll see that it jumped over to this area. I could keep adding until I get an available slot. There we go, 41 seconds in. The other way to do it is I can just click inside this graph. If I want to zoom in to make sure I'm on the edge, I can do that. There we go. I can get a larger slot time that way. I can change its message type. Maybe it's a rain only, so in this case you'll see we're going to use fewer bytes. Again, these bytes are used in capacity calculations, weather station, or a custom setup. I could tell it it's going to, maybe I have a data logger on there and I'm collecting lots and lots of data. I'm going to send it all at once. Maybe I'm going to try and send 500 bytes. So let's keep the slot where it is, but let's assume we're going to try and send lots and lots of bytes in just to see what would happen. So I'm going to hit save. Okay, so if you remember, I'm trying to send 500 bytes is what I define, but since I only have a half-second slot, I'm only capable of sending 75 bytes. So you'll see that my capacity bar turned red, kind of yelling at me that I'm over capacity by 425 bytes. Let's go back and look at the stations list. And you'll see here now we have a flag to let you know that this station is over capacity. If we scroll down all the way, see if CSAR, so CSAR is not over capacity, but let's try and add some more time to make it over capacity. So let's say we try and send 5,000 bytes. And again, I'm using really large numbers just to kind of show you what it'll look like in the list. So I'm going to go back to my stations list. Let's look at the transceivers so I can filter quickly. So you'll note that this, not only did I get the capacity flag for my transmitter, Alamo Mountain, but now I also have a capacity flag at CSAR. So CSAR is a transceiver. When we were looking at Alamo, you'll note that CSAR was able to hear that Alamo Mountain. And in this case, based on the number of bytes we're trying to pass through, I'm just going to open it, we're going to be exceeding our capacity. Our total number of bytes sent is not going to be allowed in this case. Basically, we won't have enough space or enough time to transmit the total number of bytes that Alamo Mountain was trying to pass through it. So I'm going to bring this one back down to the standard default, which is, in our case, is 25 bytes. Okay, and let's go back to CSAR and we'll see that it's no longer over capacity. And if we would have looked at it in the stations list, we'd have noted, I'm going to filter it so we can look quicker. So CSAR is no longer over capacity. Okay, so I'm going to switch now to the transceiver station page. You'll note most of it looks the same. We see frequencies, but now in this case we have two frequencies. So we have a receive frequency and we also have a transmit frequency. Information about the station kind of stays the same, lat longs, things like that, elevations. And we also have slots defined for it. In this case, what you'll note is that the frame length is 10 seconds instead of 60 seconds. And its capacity, you'll see we have a considerable number of additional capacity bars here. And the reason for that is this transceiver is listening to a gauge frequency, this F8, that has a 60-second frame length, but it transmits on a frequency that has a 10-second frame length. So basically what that means is that when we are doing capacity calculations and things like that, we listen, we get to transmit 6 times in the amount of time that each gauge station typically gets to transmit once. So we get to transmit on 6 different, what we've termed cycles. So again, it's just 60-second. We're listening to a 60-second gauge length. We're just dividing that by the frame length for the repeater in this case. And so we get to transmit 6 different times. So we have 6 different chances to send all of the different gauges that are received by this station. So again, I had switched to Ventura, so the total number of stations is a little bit different. So in this case, we're actually listening to 102 different stations. So you'll note Alamo Mountain's in the list. You'll note a number of them are blocked. So there are routes we don't believe can be successful to this station, or there's some sort of pass listing occurring. And therefore, those stations won't be included in this capacity calculation. But what we can see here is if we click on this little icon, we'll see the list of all the different stations that are being added into this calculation. Get rid of that one, maybe I'll bring up another one. You see, you know, each of them in this case is adding 25 bytes in. So incoming slots for 103 is what we can hear theoretically, not counting the blocked, including the blocked ones, but then we're only going to pass on 79 of those total blocks. So we're trying to attempt to pass a little over 2,000 bytes. Okay, any questions so far? I'm going to keep moving along. Again, we get that same frame summary graph. Okay, and in this case, we have routes to 2 different stations. In this case, based on their icons, they are receive locations. So in this case, they're base stations. I'm going to click on this Edit Routes button on the right here of this panel, just to give you an idea of the information you'll see. So what we're attempting to do here is plot the RF path between the 2 stations. So on the left-hand side will be our CSAR station, and then on the right-hand side here is the base station. So in this case, it's 15 miles, kind of a southern, pretty much directly south location between the 2 gauges. Similar path here, as you can see. So we'd expect this to be, both of these to be fairly consistent and a good path. And this is just an elevation profile between the 2 stations. I'm going to go back to a different station. Let's look at the Alamo Mountain one again and look at its routes. Okay, so as you can see, there's a couple of different, there's an additional one here due to the fact that we're looking at a different frequency. So in this case, Alamo Mountain transmits on the same frequency that CSAR listens to, that Red Mountain listens to, and that Sandstone listens to. And as you can see here, hopefully you can see that these are grayed out and we give you this block tag. We do not believe, based on our conversations with Ventura and knowledge of the area, that sandstone could actually hear Alamo Mountain. In this case, most likely due to some of these mountains here. We're sitting kind of on the wrong side of the peak here, and again over here. So fairly easy to block. Just click on the route here, and we tell you about that, tap on station name data route, so Red Mountain. So in this case, we can change it from a blocked route to a passed route, and hit save. And hopefully you can see it may be difficult with the webinar that this is now white instead of a grayed out area. So I'm going to go ahead and block that again since we're in a live system. Okay. Let's go back to Alamo Mountain, look at the CSAR again. So again, we transmit to 2 stations. We listen to 102. One of the biggest values of this is this capacity calculation here, which is going to allow us to, as we design the network, spread out the different stations as necessary. So you can see if we front-loaded this cycle, maybe we put all of the gauges that have to transmit through CSAR were on the first 5 or 6 seconds of the transmission cycle. It's possible that although this gets to transmit 6 different times during the whole frame cycle, we may be over capacity during that first part due to some unnecessary front loading. So this is a great tool to help with the network design for sure. Okay, so we showed that it's slot, showed frequencies. So at the network level, so as I indicated, most of, or all of these ones that are in this existing system are for Southern California. So I just kind of want to go through the process real quick of, first off, I'm going to show downloading, exporting a network, and then a few of the steps to import it. So let's do Ventura again. So I'm going to export their network. So I'm at the network level here. I'm on Ventura 0.1 network. I'm just going to hit download network configuration. And you'll see it just give me a standard download and a CSV file. And if I open it up, see just the standard, I open it in Excel. Basically provides us all the information we need to help rebuild this network from scratch. And so I'll just kind of go through the process real quick of how we would actually set up a new network. And just kind of show you how straightforward it is. So I'm just going to create a new network in Ventura County. So you may have noted that as I move my screen down, some of these panels shifted. That's part of the responsive design. So networks, I'm just going to add a network. And again, since I'm logged in as Ventura County, I have the ability to add a network here, but I wouldn't be able to add or edit any other agency's networks. Just going to click add. Type. So simple networks transmit directly to the receiver, so we do not have any repeaters in the system. A repeater network, all the gauges go through a repeater, and none of them transmit directly to a base station. And then a hybrid, which is the most common, is gauges transmit either to a repeater or directly to the base station or both. Okay, so I'm going to just name it Ventura Test Network. I'm going to give it the same description. You can see we can use either US units, feet, miles, things like that, versus metric if your agency uses metric. I'm just going to hit save. Okay, so you can see I successfully added a network. However, it's given me a warning, so I have not defined a frequency for the network. So I need to add a frequency. So I could do it 2 ways. I can click add, and I can import frequencies, which as you'll see here, frequencies is part of my export, or I can just add them directly. In this case, I'm just going to add it directly just to kind of show the steps. So I'm just going to name it, maybe we'll make it gauge transmission. And I'm going to make it 169,500 megahertz. And if we had any notes about it, we could put those in here. So all to sort of basic note, okay? So the next step in this is defining the frame, which is one of the most important steps in defining the frequency. So in this case, it's defaulted to 120 seconds. If I want to make it 60 seconds, I'll just change this to 60,000 milliseconds since everything is stored in milliseconds. And in addition, when you're using most of the hardware for ALERT2, have you define everything in milliseconds when you're actually setting up the hardware, which is why we default to milliseconds as well. But we try and give you some hints, you know, what is it in seconds versus milliseconds. Capacity is something that's calculated for you. In this case, we think we can send not quite 12,000 bytes of data per frame, so per 60 seconds. Slot, so in this case, we're just defining defaults. As you can see, block is grayed out, and I can't change it. That's because the block size of 250 milliseconds is just part of the protocol. It's defined and hard-coded as 250. So our default slot length, 500 milliseconds, which for looking at the list of everybody online, I think that would be the standard that you guys would use as well. So I'm going to hit save. Okay, so you'll note here I have a frequency now, the gauge transmissions frequency, and again, just the standard information about it. So I don't have any stations defined. I'm just going to click add. So I can add a transmitter, put the name, put the description on it, things like that. In lieu of doing this, since this is pretty straight ahead, I'm going to show the import tool. So I'm just going to click this import button. So what you'll see here is instead of uploading a file, we're just going to copy and paste in the information in some sort of delimited format, either comma or tab. Since I had brought in this CSV into Excel, it's going to be a tab separated. And so you can see the column headers in here. So we need the name, the description, the station type. Is it a transmitter? Is it a receiver? Is it a transceiver? What protocol is it, etc. So luckily for us, what I had exported kind of matches, it does match the same exact thing. We get the name, description, etc. So I'm just going to copy this from Excel. Since it's a CSV file, when I copy and paste it in like that, it's actually already tab delimited. So I'm just going to hit save. And there we go. Now I have 108 new stations, so very smooth, very quick way to add lots of data. You can see they're plotted on the map since they all have lat longs associated with them. We see some tags kind of hinting at us that we have issues with each of these stations. So we don't have a frequency associated with any of them, and we haven't defined a slot for any of them. So let's go ahead and do that. I'm going to click Alamo Mountain. Again, we can link frequencies. So in this case, we want to do, since it's a transmitter, in this case, we want to have it be a transmit type link to a frequency. And if I look in my drop-down, since I only created one frequency, I'm just going to use the gauge transmissions. I'm going to hit save, and now I have linked a frequency to it. So in this case, this means that it's going to transmit on this specific frequency. And if I go back to my stations list, you'll note that that tag for the frequency is now gone since I took care of that one. The other way I could have done this is if I hit this link frequency again, you'll note, again, I have an import. And I can import all of those links as well. You'll see we have links. We link it to the frequency name. So I could copy all of this and paste it in and hit save. I'm going to skip that step just since I already did one. But we could have done that to link all of the stations. Okay, so we have a frequency now. We don't have any routes yet because we don't have any stations that are listening on this gauge frequency. So let's create a new station. So I'm going to go to my network, stations. I'm going to click, I could either click add station or maybe let's do the stations list. Let's look for a transceiver since there will be the ones who listen to that frequency. So let's do Red Mountain. And in this case, I want to link its receive frequency to the gauge transmission since we're going to listen on that frequency. Okay. So if I go back to my stations list one more time, see Alamo Mountain again. So this is where we had started. You'll see I have my route. So Red Mountain is currently the only station that is listening to this frequency. You'll note my frame summary, it's blank. No slots have been defined for any stations, including my own. So let's go ahead and define the slot parameters for this station. So I'm just going to hit this add button, and I'm going to, since we're linked to this gauge transmission frequency, I'm going to click that one. As you can see, kind of a blank slate. So I can either, take the first slot here. I can define a really large slot. In this case, I'm just going to click on it, and length, I'm going to bring it back down to the standard. And so I'm just going to take the first slot in this case and hit save. Okay, so similar information to what we had seen before. It's kind of the last thing to show in here since our time is running out is, let's say this is a really important gauge to me, and since although I've defined a 60-second frame length, I know that I need to get reports in more often than that. So let's say I want this gauge to transmit twice within its frame. Fairly simple way to do that, and this would also match your equipment out in the field, how you would set it up out in the field. I'm going to edit my slot, and then I'm just going to edit my frame length. So currently I have a 60-second frame length, which matches the frame length for the frequency as a whole. I'm going to cut that in half to 30. So basically my frame length for this station is half of the frame length of the frequency. I'm going to hit save. And one thing to note, we kind of give you this information here. The frame length is currently different than the frequency frame length. So we're just kind of hinting that it's going to report multiple times. And then you can see in my frame summary here, these orange bars represent when our station gets to transmit in the frame. So as you can see, we transmit right at the beginning of the frame and then again halfway through the frame. If I click edit again, if I wanted to transmit 3 times, I would just change this to 20,000 milliseconds, and you'll see I get to transmit 3 times now. A couple things to note on this: we do some checking. So let's say you tried to set up a frame length that wasn't a multiple. Since there would be no way to actually transmit regularly using a frame length of this size, we won't let you save that information off. And again, we would do some other checking. So let's say we wanted to transmit twice and change this to 30,000. If we had another gauge that was set up to transmit on that slot that's 30,000 milliseconds in, we'd also block you from saving that. So there's lots of built-in checks and balances on here that make sure that you cannot have 2 stations set up to transmit on the same slot. Okay, so kind of covered a lot on this, especially for a new application that most of you haven't seen before. So definitely understand if there's any questions. I'm going to stay on the line here. We've used up our hour, so if there's any additional questions, go ahead and type them into the chat, and I'll try and answer them now. If not, I'd like to thank everybody for participating in this webinar. We really appreciate everybody taking time out to spend an hour with us every month to learn something new or to cover something again. So again, thank you, and happy holidays to everybody. Again, I'm going to stay on the line for a little bit longer. Feel free to type the chat. Okay, so I did get a question real quick coming in. When can we get access? So for those of you who are in the Southern California group who have agencies defined in here, we're planning on sending out those links this week, which will have your username and things like that. For those of you who are not part of this, that Southern California group of agencies, just go ahead and contact whoever your account manager is with OneRain, whoever you usually talk to talk about getting access to the tool and subscription costs and things like that. So so with that, I'm going to go ahead and put up our thank you slide. And again, if anybody's got additional questions, go ahead and type them in the chat, and I'll stay on for a few more minutes.